Our next topic is adding and subtracting integers. So to start, we need to review what it means to be an integer. By definition, an integer is a whole number that can be positive, negative, or zero. So you've been working with integers for a while. Now, in terms of adding and subtracting integers, we're going to start with the rules for addition. Rule number one is that when two numbers have the same sign, you keep the sign and you add the numbers. So some examples, if both numbers are positive, positive 5 plus positive 4, we keep it positive and add the numbers. Positive 9. And notice that we don't usually refer to this as having a sign in front of it, but it does. It's positive. If we have those same numbers, except now they're negative, negative 5 plus negative 4, we keep the sign. So our answer is going to be negative, and we add up the numbers. 5 and 4 is 9. So, if the two are positive, keep the sign, add them up. If the two are negative, keep the sign, add them up. Our second rule is what to do when they have opposite signs. When two numbers have opposite signs, we're going to take the sign of the number that has the larger absolute value. So you can really just think of it as looking for the bigger number, the number that has the bigger distance from 0. That's going to be our sign, and then we subtract the smaller number. So when two numbers have opposite signs, take the bigger number's sign, and by bigger I mean bigger absolute value, and subtract the smaller number. So, example, negative 7 plus 4. Negative 7 has the bigger absolute value, so we're going to keep the sign as negative, and then we just take 4 away from 7, which is 3. So negative 7 plus 4 equals negative 3. And there's a lot of us out there who can do this in our heads. We have good number sense and we can think about what's going on. But we just want to be careful and be aware of the rules that we're using even when we do this stuff in our heads. A lot of times I see examples of like a problem like this where people just want to add up the numbers. That's not how we want to do this, because on the number line we're starting way over at negative 7 and we're only gaining 4 spots back to the right. That's how we end up at negative 3. Now I showed you some examples which use actual numbers. We can apply these same rules to variables as well. So if I have 3x plus x, these are both positives according to what we can see, and we add them up. 3x plus 1x is 4x. So it's really important for us to remember that when we're adding, the things that we are adding are called like terms. Like terms mean they're made up of the same stuff. So both of these expressions are made up of x's. That's why we can add them together. If there was another number stuck on the end here, it wouldn't get added to these. So the 3x plus the 1x would be 4x. The plus 5 would just drop down. And this would be as far as we can go because they don't have anything in common. Notice that this would work if our numbers were negative as well. So negative 3x, this should be in parentheses, plus negative x, keep the sign negative, and add the numbers, 4x. So the same process at work here. Now let's take a look at subtraction. So by definition, subtraction really just means adding the opposite. So subtraction is a form of addition. And because it's a form of addition, it means that anytime we do subtraction, we can rewrite that problem as though it was an addition problem. So here, 35 minus 45. We can't make use of our rules of addition until we write this as an addition problem. So it means adding the opposite. So it means 35 plus the opposite of 45, which is negative 45. So now that we've written this as an addition problem, we can go ahead and apply the rules of addition. The number with the bigger absolute value is negative, so our answer is going to be negative. And we're subtracting 35 from 45, which gives us 10. So 35 minus 45, or in other words, 35 plus negative 45, simplifies to be negative 10. Here's another problem. So again, we want to rewrite this as an addition problem. So 35, subtraction becomes addition. Now we want the opposite of negative 45, which is positive 45. So subtracting a negative is the same as adding a positive. There are lots of ways to remember this. I like to say minus a minus means plus a plus. Sometimes people will go through and when two minuses are in a row, they'll just change them to positives. That's fine. Or we can rewrite it using the definition of subtraction, and we still end up with an addition problem here. 35 plus 45 equals 80. So, that's a rundown of the rules of addition and subtraction. Let's try a few harder problems. And remember also in the background, we're still following the rules of orders of operations. We're still following PEMDAS. If there's parentheses, exponents, we still have to simplify our work in the same order. So here we have a problem with some variables and some integers. We want to turn this into an addition problem in order to be able to use the rules of addition. The x drops down. I'm going to be adding the opposite of what's in there. Remember, this negative means the opposite of. So the opposite of 3x is negative 3x. And then the opposite of 5 is negative 5. Now I combine my like terms. 1x plus negative 3x gives us negative 2x. We keep the sign of the bigger number, subtract the smaller one. Now we're left with this leftover negative 5. It just drops down. I can't add it together because they're not like terms, so this is as far as I can go. I can leave it like this, or I can turn it back into subtraction. Negative 2x plus negative 5 is the same as negative 2x minus 5. Doesn't matter which way you go with this one. Let's try another. So here's a problem where we've got some negatives and we've got some positives. Again, you're welcome to read this from left to right and to go in order. Or you can make use of one of the properties that we learned about in our last lesson, the commutative property. And we can move these around so that we add the negatives together and we add the positives together separately. It just makes it a little easier. So negative 35 plus negative 5, signs are the same, keep the same sign, add the numbers. Gives us negative 40. We have a positive 14 and a positive 16. Keep the sign, positive, add the numbers. 30. Now, we go ahead and add these two. They have opposite signs. The bigger sign is negative. Subtract the smaller number. This all simplifies to be negative 10. It's going to work out the same way if you read this left to right. It just might be a little bit slower in the process that you go through. The other important thing to do is that when you're going through a problem that's sort of complicated, make sure you just take your time and do one step at a time. Simplify each thing as you go, taking your time. So we got a couple of different things going on here. We've got this situation which tells us we need the opposite of the stuff in here. We also have this going on, which is kind of a distributive property case. So here, the opposite of 5 is negative 5. The opposite of negative x is positive x. So that part dropped down to be that. We have negative 3. So this says subtract 3, but that's the same as negative 3. And we're distributing it in here. Negative 3 times 2x is negative 6x. So we can think of this negative 6x as plus negative 6x. Negative 3 times 4, negative 12. And now we go through and combine the like terms. Negative 5 added to negative 12. Keep the sign, negative, add the numbers, 17. Then we have things with opposite signs, positive 1x and negative 6x. The sign is negative. Subtract the smaller number. 6 take away 1 is 5. So negative 17 minus 5x. That's as far as we can go with this problem. They're not like terms, so we can't reduce any further. At this point, you've seen a pretty good example of the types of problems that you can come across when you're adding and subtracting integers. So go ahead and give some more problems from your homework a shot.